Hi everyone, this is John Wen. Today is July 6, 2018, and today we're gonna continue the project to talk about the workflow executor. So from last week, it's our second video to talk about this topic, and today we're gonna mainly cover the logistics regression. So firstly, let's talk about what is a logistic regression. So it is logistic regression is help to model the probability of events occurring depends on the value of independent variables, which can be categorical or numerical, and also it can help to estimate the probability that every events for the random selected observation versus a probability the event does not occurring. So it can also help us to predict the effect of series of variables, and also can help us to classify the observation by estimating the probability. And let's to talk about why we need to use a logistic regression. And because we know that we have several other like the linear regression and multiple regressions. And for the linear regression is one quantitative variable predict another one. But for some situations, our dependent variable is only a binary. It has only 0 and 1. It does not fit to be a normal distribution, or it cannot be beyond 0 and 1. So sometimes other regressions will be such a U shapes or curve shape. So that does not fit the specific situations. So that is why this logistic regression will fit to some specific situations. And today we're going to talk about the program, and that will exactly fit why we need to use a logistic regression. Firstly, let's take a look at the data we're going to work with. And so this is a training set, and we have 3 columns of data. First 3 columns independent variable, and the last column is dependent variable. So we will train a model to predict from the first 3 columns and to give out this last column value. So let's take a look at the testing set or variable set. And so we have 3 values, and we want to predict the last column. So this is a goal of today's project. So let's go back to the main.java and take a look at the code. So in today's main method, and we will firstly to instance a task T1 and as a null, and we will use a try and catch to put the class and functions inside. So we will declare a class object as task class and use a name as logistic regression. So basically it is a file name as a logistic regression.java. So we will create a class. We will declare a class object with a name as is logistic regression.java. So, and we will also create a new instance of this class. And we can see a cross line here. Basically means the new instance for this class is deprecate, and we try to fix this, but somehow we we may leave it as it is right now. And we have three catches at this point, and like the class not found exception and the instantiation exception, and also illegal access exception. And we will, if there is any exception, we will catch them and also print them out. And just like the last time, and we know that in the task class we have a function as set location. Basically we'll set the file name as a path of the location because we are in the same route. And so we will pass, as we said, we will pass a number 5 logistic file and as a matrix or the training set, and we will also input the testing set, and we will also specify the output file, and we will write the output into and then we will call the run function from this logistic regression class or object. So let's take a look at the run functions here. So let's firstly take a look at this class logistic regression, and we will define a vector of vector type of double. Basically X will be a matrix, and we'll put all the independent variable and to put into the this matrix, and we will put the dependent variable into the Y vector, and it will be a one-dimension vector. And then we will put the test X because we know it's only one row of records, and so we will put into a one-dimension vector. And we will also define a theta array because we will do the training the mode, and we will basically adjust the theta, and in order to lower the cost loss function, and then in order to realize a very small loss function, and then we can get the correct model. So let's go back to the run function, and firstly, and we will define the matrix file, and by getting the file name. So we can take a look at this get file name, and basically we'll return a location. That means here we will return just the file name, just as the number 5 logistic. So let's go back, and same thing, we will get the X vector file and as a location, and to put into this string. Basically this is a X test file path, and then we will read the matrix from the file, and this is method, and to read from the first from this file number 5 logistic. Basically we will read them into a matrix. Remember at the very beginning we defined the X and Y because we will need to put the training set into the matrix X as all the independent variables, and Y as the dependent variables. So we can take a look at this method in this class. So basically we'll take a CSV file name, and here we know it's a number 5 logistic, and if there is an exception it will throw the IO exception, and basically it's quite same as the last time, and we will use file reader and also the buffer reader, and to put them in a string, and we will also read the string line by line and until it's empty. So for every line we will split them by comma. So we can see from here we are split them by comma, so we will here we will split them and get them into get them into the vector. So, but firstly, we will put a new value as 1.0 to be the first element of each row, and then we will put them all the value after this 1.0. So, and then we will also put the so we will add each line to the x, and finally the x will be a matrix, and we will also add the last column value to the y vector. And after doing all the things in the try brackets, and we will do the finally, and basically we will close the string. So this is a read matrix from file function. Let's go back. So here, now after we execute this line, basically we will get the x and y matrix and vector ready, and then we will also do the similar things to put the text x into the vector. And let's take a look at the code here. So basically it's the same, it's quite the same, and except it's one dimension. And they will also use a file reader and buffer reader to put them in a string, and until it's not empty, and we will split them by comma, and then to put them into the data line. Put them into a data line, and then we will finally return this data line, and before this we will close the string. So so basically it's quite same, and we will get the y size of y and as m, and also every row's size in x as n. So basically let's take a look at the size of every rows of x will be 3 plus 1, because we put a 1.0 at the beginning, and so it will be 4. And for the y, we have 5 elements in the vector, so it will be the length of 5. So let's keep looking at the code, and here we will catch one IO exception, and we will print out the exception if there's any. So next step is we will train the model, because we have prepared the data as a training data and testing data. And so here we will get the x, because this is all the independent variables in a matrix, and we will get the first row and get a size and put into n. And we will also define the theta, and theta is a length of n array, and we will initialize them as 0.1 for each element inside. And then we will go to the training steps, and firstly we will do a gradient descent function. So let's firstly take a look at this method, and basically we'll take a variable as input as learning rates, and basically it will get a size of y and also the theta size. The theta size means also equals to the each rows of x, the size of each row of x, and also we will define new array named delta theta, because we will adjust the theta based on the delta theta. And we also will initialize the delta theta as 0 for each element inside. And also, so from here, we will check each row of the x, because we have m is a y, size of y, that means we will check each row of the matrix x, and we will get the. So here is a very important thing of each method. And let's take a look at this each method. So before talking about this, and I hope to bring up a topic in the logistics regression, and it is called the logit. And in logistic regression, we're estimating an unknown p for any given linear combination of independent variables. So therefore, we need to link together the independent variables to essentially and the Bernoulli distribution. That link is called the logit. However, and also the goal of the goal of logistic regression is to estimate the p for linear combination of the independent variables. However, when we get this logit in graph, we will notice that it will be a sigmoid curve between 0 and 1, but it is for the x. But actually, we need to get a graph and that is able to get a y, get a value of y. So that is help us to. That is why we introduce a new concept as inverse logit. And basically, it's the same. It's a very similar idea, but it's also it will take the inverse of logit function. So we will see here the result will use the inverse logit function and to calculate the value as result and then return this result. So this H method will take each row of x and the current theta, and then will return. Then it will return the inverse logit and as a return value. And but inside we will get this result by to add the value of the each element times the theta. Remember, at the beginning we set every theta to the 0.1. So actually, we will add them all into the result, and then we'll put it into a math except a minus result, and then basically will give us the result as 1 or 0. So let's go back to the main method, the logistic, and go back to okay. So here we're staging the gradient descent, and now we get a inverse logit value returned as a result, and it could be 0 or 1, and it will get compared with the actual value, because we know y contains all the dependent variables, and we'll check with the actual value, and then we'll get a difference. And this will be because if we get a difference, and then we will be able to check how big is the difference from current model and the reality, and then we will calculate it based on based on it we will calculate the delta theta, and finally we will adjust the theta based on the current delta theta and also the learning rate, and we will basically minus the learning rate times the delta theta. So you can see at the beginning we are setting the learning rate as very small. Let's go back and take a look. It's 0.00005, and it's very small, and I tried and I spent a whole night and it haven't reached out very good convergence. of the loss function. So I think I might get a bigger, larger, and then to get a better or faster result. So here in the gradients descent function, it will help us to adjust the theta, and also, so now we will check the j. Oh, sorry, here is a typo. J function, j method. So let's take a look at here. So j will help us to calculate the loss function and loss value, and basically we will get the quite similar thing, because we just based on the gradient descent function or method, we will get a new theta, adjusted theta, and now we will put them into the X matrix again, and to get the inverse logit again, and then we use this H value, the inverse logit, to calculate the loss value, and finally we will return this loss value to here, and to judge if it is less than 0.1, sorry, and if it is less than 0.1, and it will break. Otherwise it will print out current loss function or loss value, and then it will keep running and keep running, and again it will go to the gradient descent method and to do the adjustment of the theta, and finally it will reach a value less than 0.1. So if we are able to find one, and then we will print out the final loss value is here is j method return value, and also we will get the final theta, and we will see system print out that theta value, and we will also print out the text x, and finally, if we are, because remember we get the result from the inverse logit, and if it is basically it's a probability. If it is larger than 0.5, and that means we are more it's much bigger possibility to get 1, so we will set a 0 to result to the 1, and otherwise we'll set a result to 0, and so finally after we gather this result, and we will put them into the file, write into the file, because just as we initially defined that the output text will be here, output 100, so then we will get either a 1.0 or 0 value. So so basically this will be the, so yeah, I think that's the most thing. Last thing is to log out the T1 execution is complete and check out output in the output file. So basically this will be the overall overview of the logistics regression, and this is a simple that project that defines or utilizes logistics regression methods or algorithm, and hopefully we can use it more in similar situations afterwards, and maybe we can get better understanding along the way. And even though right now maybe I can miss a lot of things, but this is the all contents for today, and until next time, happy coding. Thank you for your time.